You know, every single time you go online, whether you're sending an email or just scrolling, your data is taking this incredible, invisible journey. Today, we're going to pull back the curtain just a little and follow one of those tiny pieces of data on its grand tour across the internet. Think about it. You click a link and a video just starts playing. It feels totally instant, right? Almost like it's magic. But what's actually going on in that tiny little moment? Well, it's not magic, but it is a journey. And it's honestly one of the most fascinating processes that makes our whole modern world work. So let's just dive right in. Every single thing you do online, sending a message, liking a photo, anything, it all gets broken down into these tiny pieces of information. And these little pieces, well, they're the real heroes of our story. Each one of these pieces is called a packet. And the best way to think of a packet is like a digital postcard. It's got a tiny chunk of your data, the message, and it has an address for where it needs to go. The entire internet, literally the whole thing, runs on sending these little postcards from one place to another. Okay, so for these packets to actually get anywhere, the network has to do two really fundamental jobs. And to understand them, let's just use a simple road trip analogy. You've got the big picture job, which is planning the entire route, and then you've got the moment-to-moment job of just making the right turn at each intersection. So that first job is called forwarding. This is the in-the-moment decision. When your little digital postcard gets to a router, which is our digital intersection, that router makes one simple choice. Which road does this take to get out of here? It's a purely local decision. That's it. It's kind of like this. Forwarding is just about navigating one single highway interchange. The router isn't worried about the final destination way over in California. Its only job right now is to figure out how to get off this one exit in Ohio to keep the trip moving along. And then there's the second, much bigger job. That's called routing. This is the network-wide process. Routing is what created the entire map for the trip before your packet even left your computer. It's the intelligence that figures out the best overall path from start to finish across the whole network. So, to really boil it down, forwarding is local. It's one router asking which way out. Routing is global. It's the entire network asking what's the absolute best path to get there. Forwarding is making the turn. Routing is having the map. Okay, so if routing is all about making that map, how does the network actually create it? I mean, how do all of these different routers agree on what the best paths are? Well, it turns out there are two main strategies or philosophies for building these maps. It all comes down to something called routing algorithms. They're essentially the rules that let all the routers talk to each other to figure out the most efficient routes for all those millions and millions of little packets. So let's break these two down. On one side, you have link state algorithms. You can think of this as the GPS approach. Every router gets a complete top-down map of the entire network. It sees everything. And with that global view, it can calculate the absolute best path. On the other side, you have distance vector algorithms. This is more like following road signs. A router has no idea what the whole map looks like. It just asks its immediate neighbors, hey, how far are you from the destination? And it builds its knowledge one little piece at a time based on their answers. And hey, this isn't just theory, right? These are real-world things. OSPF is a super common protocol that uses that GPS-style link state approach. It's really powerful and it scales well for huge, complicated networks. On the other hand, a classic protocol like RIP uses that road sign or distance vector method. It's a lot simpler to set up, but it's not nearly as efficient for those bigger networks. So you see, there's always a trade-off. All right, but things get even more interesting because the internet isn't just one giant single network. It's actually this massive collection of different networks from your university, from your internet service provider, from big tech companies, and they're all connected to each other. Each of these big networks is called an autonomous system, or an AS. And a great way to think of an AS is like a country. It has its own internal road system, and it manages all of its own traffic. Your data packet's grand tour often means it has to travel through several of these countries. So, how does our little packet actually cross these digital borders? Well, first, inside its home country, or AS, it uses an internal protocol, something like OSPF, to find the fastest way to a special gateway router. You can think of this like passport control. Then, to travel between these different countries, a whole different protocol is needed. This is where the Border Gateway Protocol, or BGP, comes in. BGP is basically the language these different networks use to tell each other which destinations they can reach. It's the protocol that truly glues the entire global internet together. And after all that, after navigating all that complexity, our little packet finally arrives. Which brings us all the way back to that simple click we started with. So really, the next time you click play on a video, just take a moment. In that split second, hundreds of these tiny packets have already completed their entire grand tour, navigating local intersections, using a global map, and even crossing digital borders just to bring that content right to your screen. And you have to remember, this isn't just happening for your video. It's happening for everyone all the time. Billions of these incredibly intricate journeys are completed successfully every single second all across the globe. The scale of that coordination, it's just staggering when you think about it. So, what's the big takeaway from all this? It's simply this: the internet isn't some abstract cloud. It's a real physical system of cables and routers. And every click you make kicks off a physical journey, an invisible dance of cooperation between countless devices, all working together perfectly to get your little digital postcard where it needs to go. It's this quiet, invisible miracle happening all around us, all the time.